Hello viewers, you are welcome. Today we are going to learn uh, the arrangement of resistors in the bracket circuit arrangement. We normally have two ways of the arrangement of resistors. We have series arrangement and parallel arrangement. These are resistors. These are what we call resistors. These are resistors under series arrangement. They are connected one after the other ones. One come after the other. This one are resistors under parallel arrangement. They are connected across each other and they must meet between 2 points of the circuit. This is the circuit. This is what we call the circuit. This is the circuit also. In the circuit, we have EMF of the cell, electromotive force of the cell. This is EMF of the cell, electromotive force of the cell. This is PD, potential difference. PD given by V1 and PD given by V2. VD, potential difference. Another one is B. B is volt. Volt is SI unit of electromotive force of the cell. Also, SI unit of potential difference. This arrow indicates the flow of the current. This is current donated by I. It flows around the circuit. It flows from positive terminal to negative terminal around the circuit. And for the EMF of the cell, electromotive force of the cell, potential difference, and volt, I'm going to define them and display their definitions on the screen. As you're watching, you can pause or screenshot and copy them on your notebook. You can copy them on your smaller notebook. In series arrangement, there are important points to be noted. Point number one. There is only one path for the flow of the current around the circuit, and current flowing across each resistor in the circuit is the same. And like resistor 1, resistor 2 is the same. Let's say total current is equal to current 1 is equal to current 2 and is equal to current 3. This is all about current flowing across each resistor. Point number 2, the potential difference across each resistor is different based on their resistance, of which the potential difference across the whole combination is equal to B1 plus B2 plus B3. This is where we are going to get the formula for the resistors in series arrangement. We have Ra is equal to R1 plus plus R2 plus R3. This is the formula for the resistors in series arrangement. That was all about series arrangement. Let's come to parallel arrangement. In parallel arrangement, the resistors are arranged across each other. This is resistor 1, resistor 2, and resistor 3. And they must meet between 2 points. They meet at this point and at this point. And for parallel arrangement, there are points to be noted. Current, point number 1 in parallel arrangement, current has more than one pass when reaching a point where different resistors meet and it splits. It splits into different resistors. Like here, current splits at this point where different resistors meet. It's flow into resistor 1, flows into resistor 2, and into resistor 3. We call this one current 1, this one current 2, this one current 3. They pass into different resistors and come this side and combine at this point and moves as one current. From here, the effective current is equal to current 1 plus current 2 plus current 3. Point number 2 in parallel arrangement, the potential difference across each resistor is the same. The potential difference across each resistor is the same, and it gives the EMF of the cell. The potential difference across the whole combination is equal to B1 is equal to B2 is equal to B3. This is where we get the equation of parallel arrangement, whereby the reciprocal of effective resistor is equal to the reciprocal of resistor 1 plus the reciprocal of resistor 2 plus the reciprocal of resistor 3, and so on. This is the formula for the resistors under parallel arrangement. Now we are coming to the last part of arrangement of resistors or circuit arrangement. The last part of circuit arrangement is how to derive the equations of the resistors. Equation number 1, effective resistors, which is Ra is equal to R1 plus R2 plus R3 and plus R4 if there is R4. This is the first equation. Equation 2, the reciprocal of effective resistors. This is the equation of parallel arrangement. The reciprocal of effective resistors, which is reciprocal of Ra is equal to the reciprocal of R1 plus the reciprocal of resistor 2 plus the reciprocal of resistor 3 plus so on. This is last equation. These are the equation for the arrangement of resistors. This is equation for series arrangement. This is the equation for parallel arrangement. In series arrangement, we said before current is the same at all points across the circuit. Current is the same at all points across the circuit. And potential difference across the whole combination is given by B1 plus B2 plus B3. Okay, we are going to derive RA, which is effective resistors, is equal to R1 plus R2 plus R3. As we know from Ohm's law, let's see. From Ohm's law, we say B is equal to IR, whereby we say current is directly proportional to potential difference, whereby R is constant. R is constant. From here, we are going to substitute B from IR. Going to substitute B is equal to B1 plus B2 plus B3. Let's substitute. B is equal to B1 plus B2 plus B3. Instead of writing B is equal to B1 plus B2 plus B3, we are going to say IR is equal to IR1. We are substituting B. IR is equal to IR1 plus IR2 plus IR3. From here, we have common factor. The common factor here is I. Let's say IRA, which is effective IR. Let's say IRA, which is effective IR, is equal to IR1 plus R2 plus R3. Close our bracket. From here, we are going to divide everything by I. I goes with I. I goes with I. We are going to remain with RE. It's equal to R1 plus R2 plus R3. This is our equation. This is the equation for series arrangement. In parallel arrangement, we said before, effective current is equal to current 1 plus current 2 plus current 3. The potential difference across each resistor is the same and is equal to the potential difference across the whole combination, whereby we say B is equal to B1 is equal to B2 is equal to B3. Here you have I E is equal to I1 plus I2 plus I3. We are going to substitute from I is equal to B out of R. We are going to say B out of R E is equal to B out of R1 plus B out of R2 plus B out of R3. Since here we have common factor, we are going to pull out the common factor, and the common factor is B. We are going to have V out of R E is equal to V, open our bracket, 1 out of R1 plus 1 out of R2 plus 1 out of R3. Close our bracket. What we are going to do here is to divide everything by B. Divide this side by B. B goes with B. B goes with B. We are going to have members. From here we are going to have 1 out of R E is equal to 1 out of R1 plus 1 out of R2 plus 1 out of R3. This is the equation for the series for the resistors under parallel arrangement. From here we are going to have our last equations for the arrangement of resistors. Let's start with series arrangement. In series arrangement, we have R E is equal to R1 plus R2 plus R3. This is first equation. The second equation is for parallel arrangement. We have 1 out of RE is equal to 1 out of R1 plus 1 out of R2 plus 1 out of R3. These are all our equations for the arrangement of resistors. You're welcome. Thank you for watching.